think I might have said that that last video was the last one in this section, but I apologize. There was one more page hiding out that had fallen on the floor for me. So glad I found it, because then you would have been missing a video, which probably would have been worse. This is the last topic in this section. I absolutely positively promise it. We are going to be talking about a standardized statistic, or a z-score. Okay, and what this does is it measures how far a single data value is from the mean, measured in standard deviations. Okay, what z-scores let us do is very quickly figure out how unusual a value is within a data set. And what I like to use it for even more often is it allows you to compare values that aren't part of the same set of data. So let me tell you what we mean by that. So I think we all know that on average, men are taller than women are, okay? But how would a woman who's, say, 5'10" tall compare to other females versus a male who's, say, 6'2" compared to other males? Who would be taller relative to the men or the women? Okay, you can't just look at the guy and go, oh, well, he's taller. Yeah, he's taller, but compared to other men, and then the woman compared to other women, are they actually, who's the tallest? So literally, z-scores will let you compare, like apples and oranges, two things that are completely different. All right, so real quick, let me tell you how it is you calculate a z-score. It's pretty simple. Okay, so a z-score, and yes, that's how I make my z's. I draw a line through them so they don't look like my 2's, okay? For a z-score, you take the data value, whatever that happens to be, you subtract the mean, and you divide that difference by the standard deviation. Okay, data value minus mean divided by standard deviation. So let's do a couple here. The math SAT has a mean score of 500 and a standard deviation of 25. Find and interpret the z-score for a student who scores a 525 on the math SAT. Okay, now there should be some common sense hopefully happening behind this one. Okay, if the mean is 500 and someone scored a 525 and the standard deviation is 25 points, hopefully you'll see that, oh, they're one standard deviation equal to 25 points above the mean. And that's exactly what this calculation will show us. We're going to take that person's score, the data value, minus the mean of 500 and divide by 25. That's 25 over 25, or 1. Okay, so what does that tell us? So it said find, and then we're back to that and interpret. Okay, and interpret. That's going to be important. So this means the student scored one standard deviation. I'm going to again use SD above the mean. Okay, they scored one standard deviation above the mean. Now, let's look at another student who scored a 493 on the math SAT. So we're going to take a look at this person's z-score. I want you to notice that this person scored below the average. Okay, below the average. So since they're below the average, that's going to change the sign on the z-score. This z-score should be negative because we're below average. So we take the score, 493, subtract the mean of 500, and divide by 25. So we get negative 7 over 25, which is negative 0.28. Okay, and again, what does this mean? The student scored, and notice I'm not going to say negative 0.28, I'm going to say 0.28 standard deviations below the mean. Okay, we don't say they scored negative standard deviations. Okay, that would be like saying you measured negative inches tall. It doesn't work that way. The above and the below are what is done in terms of positive values. We say above, below are negative values. okay, above and below the mean. All right, so last one, let's do one of the comparisons here, okay? So still lots of times we've got students that will take the SAT and the ACT, but they're not scored the same way at all, okay? Not at all. So how do you know which one you did better on? Okay, how do you make a comparison? Well, let's make the comparison. So for the SAT, we're going to use the z-score, okay? So the z-score is the person's score, so 545 minus the mean of 500 divided by the standard deviation of 25. So we get 45 over 25, which is 1.8. Okay. When we look at the ACT, the score was a 25. The mean is 21. And the standard deviation is 3. So that's 4 over 3, which is 1.33333, etc. Okay? So, in which case did you do better? Well, in which case were you more above the mean? So when we talk about making a z-score, what we end up doing is the mean ends up being 0. 0 standard deviations from the mean. Okay, that's what a z-score is. How many standard deviations are you from the mean? If you are at the mean, you are at 0 standard deviations. You're sitting there, okay? So which one is further from the mean? 1.8 standard deviations or 1.3 standard deviations? Well, if you're thinking about a number line, 1.8 is further from 0 than 1.3, okay? So the conclusion would be here, you did better on the SAT because you were more standard deviations, again, SDs, above the mean on the SAT than on the ACT. Okay, so z-scores let you make those comparisons. Yes, you do need to know the formula for a z-score. Again, it's not a difficult one. Data value minus the mean divided by the standard deviation. And yes, you need to be able to do that one, I'm going to say by hand, but with your calculator. Your calculator, however, isn't going to do that z-score conversion for you. Okay, now we're done with section 3.2, I promise. And one more section to go in chapter 3, and we'll be done with the entire chapter.